Welcome, class, to your online portion of your lecture for this week. And this week we're going to be talking about a very important subject, temperature and states of matter. So the first topic, temperature, is very important to understand from a theoretical point of view as to what temperature is. And to do this, we have to understand, first of all, one of the most important principles of physics, and it's something that you all are familiar with, which quite simply is stated that all matter is made of atoms, period. Now, this might seem so completely obvious that it doesn't even need to be stated. However, it's this idea is really core to a great deal of physics. In fact, Richard Feynman, who I've mentioned before, he was a great physicist, said that this was if you could transmit one piece of scientific knowledge, this would be the most important piece to transmit. If everything else was going to get lost about science, as long as we knew this, we'd have something to work with. So how does this relate to temperature? Well, let's take a look at some matter at an atomic scale. And we'll be talking about states of matter later, that is solids, liquids, gases, and plasmas. But let's just look at a gas right now as our example. And you're all familiar with this idea that a gas is simply a great deal of atoms or molecules floating about in a given volume. So these are, let's consider this a hydrogen gas. So each one of these is a hydrogen atom, and they're simply floating about. Now, we want to know what is the temperature of the gas. So you stick a thermometer probe into the gas and read the temperature, right? Well, what's that probe reading? Let's talk about it. Each atom or molecule, and actually in a hydrogen gas, just so you know, it's usually in the form of H2. So you've got two hydrogen atoms bonded to each other. In the drawing, I just drew a hydrogen gas with one H, but in pretty short order they would bond together and you'd end up with H2. So just FYI. But anyway, it's kind of besides the point. We have these molecules, or these atoms, floating around. And what are they really doing? Well, each one of them is moving in a particular direction with a particular velocity. Now remember from vectors, velocity, there's the symbol for a velocity vector. We've got our vector symbol above it, and V for velocity. It has a direction and a magnitude. And the magnitude is indicated by the length of the arrow. The longer the arrow, the faster the molecule. So I'll draw a fast one. This one's really cruising. Okay? And then this one isn't going so fast. And you can imagine all of these atoms bouncing around in this gas. And every once in a while they hit one another and they have a collision and they exchange some momentum and energy, and then they keep going. All together in the volume of the combined gas, the energy and momentum stays the same. Unless, of course, it's interacting with the wall of its container, but we're ignoring that for right now. So there you go. There's your gas. It's at a given temperature, and it's all bouncing around. Now, if you start adding up all the vectors, so V1, V2, V3, V4, V5, and I'd be here for quite a while labeling every gas molecule. But if you add up all of those vectors and then take the average of the velocity, you're going to get a particular number. So let's take a look at how this works out mathematically. And again, you're not ever going to have to do this math, so we can kind of look at it in more broad strokes than in particulars. So there's a couple things you can do with the data. You can take the V, the average velocity. It's going to give you some number, okay? You can also calculate the energy, because remember, the energy of the particle, the kinetic energy, so E, K, is going to be 1/2 mv squared. So this is your velocity right here. And of course it's a vector. Sorry, I drew that in the wrong spot. There's your velocity, and the mass would be the mass of the atom. So you could get the kinetic energy average. Okay, that would be another number you could get. And you can also do some statistical analysis to this data. So let's look at a graph. So this on this axis here is going to be number of atoms. And on this graph, or on the other axis, the x-axis, the y-axis, we will have energy, or kinetic energy, EK. So, again, looking at your gas, if here's 0 atoms, and here's, right here is 1 atom, and right here is, say, 1 billion atoms. Okay, you might have 1 atom that has an extremely low kinetic energy, almost next to 0. Say it was just in some kind of strange collision with a number of other atoms, and all of a sudden it came out hardly moving at all. If you picture a pool table, a bunch of pool balls all hitting each other, and one of them is just kind of stationary. So one of those atoms is hardly moving in that whole volume of gas. And then, maybe at around 10,000 atoms, they're moving a little bit more. And you might have, I think I made a mistake. Okay, hold on a second. Yeah, we made a mistake. Real simple correction. Hope this doesn't confuse things too much. This is going to be the number of atoms at a particular energy, and this is the energy. So we have 1 atom at very low energy, and then let's say you have 1 atom at extremely high energy, and it's going super, super fast. Okay, so it's very far away on the x-axis here, so it's got a very high energy, but there's only 1 of them. But you have, say, most of your atoms have some medium energy. So this is a big number of atoms. Say this is your billion atoms right here, and then this is 1 atom up here, and then this is 1 atom down here. Anyway, you connect the dots, And you end up with this familiar shape in statistics called a bell curve. Okay? You're familiar with this idea that, and this is that most of your atoms have an energy right in the middle. Well, this is proportional to the number called the temperature of the gas. So temperature is a measure of the average kinetic energy of the gas. Please write this down. Temperature is the measure of the average kinetic energy of, now not just gas, by the way, it could be anything. We used gas in our example, but of any substance, of the substance. Please write that down. Okay, we'll continue with the next video.